Now, limiting reagent. Sometimes a question will suspiciously give you too much information for you to calculate. Here's an example. So here, a solution containing 20 grams of dissolved sodium hydroxide and to add it to 25 grams of copper nitrate. What is the mass of the precipitate formed? Here's an equation. And again, we have balanced it for you. And you will notice that here we are given two amounts, right? Two masses of one mass for sodium hydroxide and the other mass for copper nitrate. Now, the question is, well, suspiciously, we have two quantities. Which one? We can use either one, but which one should we use? So the idea behind this kind of calculation is this. Okay, so let's say we need to make a skateboard. A skateboard is made from a deck and 4 wheels. Now, if we have these amount of wheels, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 wheels and 2 skateboards. How many skateboards can we actually make? Well, the answer is 2. And of course, we would have 2 wheels left over, right? But in this case, we're using the deck, which is the limiting ingredient, to do our calculation. So this is the very idea of limiting reagent calculation. So the quantity of reactants supplied are not exactly the same ratio as shown in the equation. Then the reactant that's completely consumed is the limiting reactant. The other one will be the excess reagent. So which one do we use to do stoichiometry? We use the limiting reagent, okay? Now, based on the stoichiometry ratio, we know it's 2 to 1 between sodium hydroxide and copper nitrate, which means by the amount, we will see that sodium hydroxide is too much, because if we only have 0.133 mole of copper nitrate, then we can only react double the amount, which is 0.266 mole of sodium hydroxide, right? Okay. So as a result, we use the limiting reagent, the quantity given by the limiting reagent, to work out the product that's formed. So we use the amounting mole for copper nitrate to work out the precipitate here, which is copper hydroxide in the reaction.